reflection, and congruence. We start with geometric transformations. Now, a geometric transformation is an operation that changes the position and/or the appearance of a geometric figure. The figure to be transformed is called the object, and the figure that is obtained after a transformation is called an image. The transformations which change the position of a figure without changing its shape and size are called isometrics. An example of an isometric transformation is reflection. Before we look at reflection, let us look at something called the lines of symmetry. A line of symmetry is an imaginary line that can be drawn through an object where one side is a perfect reflection, a mirror image of the other side. You can think of a line of symmetry as a line on which you can fold the image. If both halves line up perfectly, then that is a line of symmetry. If they don't, then it is not. This butterfly, for example, has a vertical line of symmetry. If you were to fold the butterfly at the line, each half would match exactly. These are called reflections or mirror images. Because both sides are reflections or mirror images, this is also referred to as reflection symmetry. Let's see a few polygons and see how many lines of symmetry they have. An equilateral triangle has 3 lines of symmetry because it can be folded along each of the 3 lines and line up perfectly. An isosceles triangle has only 1 line of symmetry because it has only 1 line along which it can be folded perfectly. A scalene triangle has no line of symmetry. A square has 4 lines of symmetry. A rectangle has 2 lines of symmetry. A parallelogram has no line of symmetry. And a rhombus has 2 lines of symmetry. Next, planes of symmetry. Now, we have seen that some plane figures have lines of symmetry. Consider a 3-dimensional solid like a cube. Can you locate a line that divides the figure into 2 equal halves? None. In fact, no line can divide a 3-dimensional solid into 2 halves. Only a plane can divide a 3-dimensional figure into 2 halves, and such a plane is called the plane of symmetry. This is a plane of symmetry of the cube. How does it divide the cube? Like this. Now we have 2 equal halves. Taking a fresh cube, another plane of symmetry divides it like this, and again 2 equal halves. The 2 halves are exact mirror images of each other. So this is another plane of symmetry of the cube. In fact, a cube has 9 planes of symmetry. Now, congruence. Congruent means having the same measure. Figures are congruent if they have the same size and shape. The 2 triangles are congruent. They are both triangles of equal size and shape. Two congruent shapes may have different orientation, but will be able to fit together perfectly. These 2 shapes may look different, but if they were turned or flipped, they look identical. It is important to remember that shapes are only congruent if they can be turned or flipped to look exactly the same. Shapes that look alike but are different sizes are not congruent. Now to reflection. A reflection is a transformation that flips a shape over to create a mirror image. In this example, the triangle on the left has been reflected, flipped over the dotted line to create a mirror image. We can also say that the vertices of the triangle A, B, and C have been flipped over the dotted line to create mirror images as another triangle A', B', C'. In a reflection, points on the object and their corresponding points on the image are the same distance from the mirror line. A line joining two corresponding points on the image and object is perpendicular to the mirror line. In a reflection, the object and the image are congruent. Now, to be able to reflect an object on a mirror line, you only need to remember two things. 1. A point on the object and its corresponding point on the image are equal distances from the mirror line. And 2. A line joining the two corresponding points is perpendicular to the mirror line. In view of this, a point on the mirror line is unchanged in a reflection. So let's reflect the triangle PQR on the mirror line MM. What we need to do is to draw perpendiculars to the mirror line from the vertices. We start with P, place the compass there and make an arc that cuts the line at 2 points. Place it on the other point and make another arc. Go to the other point and do the same. Now join P to this point of intersection. With a ruler or straight edge, measure the length from P to the mirror line. Now take the same length on the other side and we have P'. We go to Q, place the compass and mark an arc. Place it here and mark another arc on the other side. And again place it here and another arc to intersect with the first one. Now draw a line from Q to this point of intersection and extend the line. Take a ruler and measure the distance from Q to the mirror line. Take the same distance on the opposite side and we have Q'. Lastly, we have R. Yeah, that should do. Mark an arc, then come here and mark another arc. Come down here and make an arc. Join point R to the point of intersection of the two arcs. Take the measurement from R to the mirror line and measure the same distance on the opposite side. And we have R'. Now the last thing is we complete the image. Now, ever so often, you will reflect images on a Cartesian plane, because only then can you give the coordinates of the vertices and also the equation of the mirror line. but the principle remains the same. You draw perpendiculars to the mirror line from the vertices of the image. You take the same distance from the mirror line to locate the points on the image. And once you have all the vertices, you can complete your image. And once you have done that, you have your reflection. Lastly, locating the mirror line. Now, in certain cases, you could be given an object and its image after reflection, and what you are required to do is find the mirror line. Knowing the properties of reflection, that should be easy. To locate the mirror line, you join any two corresponding points on the object and its image, and then you draw a perpendicular bisector of your line, and that bisector is the mirror line. So for these two triangles, we join B to B prime. And now we bisect this line. Open your compass to more than half the length of the line. Mark an arc from the top to the bottom to intersect the line. Now move the compass to the other point, maintaining the same radius, and again mark an arc from up to down. Now the two arcs have intersected. I will close the compass now and draw the bisector. This line is the mirror line. It's MM. That's pretty much about reflection. I will leave you to watch this reflection of triangle ABC